Alrighty, ladies and gentlemen, we are starting off with a little more algebra review here. Looks like we got a slight typo with this bad boy. It should be 2x squared. So how are we going to solve that one? We're going to do 2x squared plus x, and we got to set that bad boy equal to 0. So I'll subtract the 10 over. So now I got to factor. Oh my goodness, I had to factor with the leading coefficient. Again, Mr. Allen is relentless. So if we do, let's see here, let me change my marker color. 2 times negative 10, that's negative 20. Whoop. There we go. And what do I want to add to? I want to add to 1 due to this 1 that would be right here. All right? Okay. All right, well, what two numbers multiply to negative 20 and add to 1? Well, I'm thinking of like 5 and 4, and the difference of those is 1. So one of them's going to be negative, one's going to be positive. That's why I was thinking like difference instead of sum. So one's negative, one's positive. Those will then add up to 1, right? So if I did 5 minus 4, woo! All righty. So I'm going to have 2x squared plus 5x minus 4x minus 10 equals 0. So remember, it's only changing this guy into these two. 5x minus 4x is 1x. We just split it apart so that we can group, factor by grouping now. And keep that negative sign in with the 4 in that group. That's going to help with the GCF action. Okay, so this first one I can only take out an x, and I'm left with 2x plus 5. And the next one I can take out, it looks like a negative 2, and I'm left with 2x plus 5. It is not a coincidence that those two are the same. So I have x minus 2, and I have 2x plus 5. That equals 0. So if I solve it, I'm going to have x minus 2 equals 0, so that's x equals 2. And then here I have 2x plus 5 equals 0. And I'm going to get x equals, I'll subtract 5 and divide by 2. Boom, those are my two solutions. And I'm just going to leave it as those. There's no like original or like, context of an original problem, like a perimeter or, side length, angle measure, whatever that we have to plug in to see if it's positive or negative. So we're just going to keep those two answers. All right, next one. Given the distance between the 2 points is d equals 10 and the coordinates are 8y and 2, 3, find y. So we can do these problems for x or for y. The last one was y. This one's y again. It's just, again, a coincidence that happens. So let's make sure we have some room to work. I'm going to make this quite a bit smaller so we can do a little bit of work over here. Okay. So I know the distance is 10 between those two. So that means 10 is my distance is equal to, well, what's my distance formula? I'm going to subtract my x's, 8 minus 2 squared plus, I'm going to subtract my y's. And I always suggest to keep the unknown variable first and then subtract the known number. It's just going to be a little bit nice. You're not dealing with a negative number that way. I mean, you could deal with a negative y. It could be 3 minus y. It's the same thing. But I like dealing with positive variables whenever possible. And since you're setting it up, that makes it a little bit easier. All right. It's your choice to make it that way. So what do I need to do here? Well, got a couple things. Why don't we simplify what we can here? So this is 10 equals, and then 8 minus 2 is 6, squared is 36, plus y minus 3. Now, if you were thinking, oh, hey, why don't I just cancel out my square root with these two squared guys here? You can't do that, okay? You cannot just cancel those out because you have addition going on in here. It does not allow you to do so, okay? That's like saying, as a sidebar here, that's like saying, let's say we have square root of 16 plus 9. That's not just 4 plus 3. That is not the case. That's 7, right? Square root of 16 plus 9 is the square root of 25, which is 5, right? We should get the same answer if it would hold true, and that's not the case, okay? So you cannot just, square root both the 16 and the 9 to get 4 and 3 and add them together. It doesn't work that way because of that addition that's happening on the inside, okay? All right, so that's just a little sidebar there. Not part of this problem, but an illustration of it. Okay, so what do I need to do? Well, how about I square both sides here? So if I square this side and I square this side, that will cancel out the square root, and I'm left with 100 equals 36 plus y minus 3 squared. Now I can subtract that 36 and get 64 is equal to y minus 3 squared. At this point, I'm going to go ahead and square root. I can do that now because that y minus 3 is inside the parentheses getting squared, right? So it's inside the squared part, so I can do that to cancel that out, and I'm left with 8 equals y minus 3. But since I square rooted both sides, I do have to account for both the positive and the negative version. So you can think of this in as like two separate problems if you'd like. Might make it a little bit easier for you to manage. Y minus 3 is equal to 8, and y minus 3 is equal to negative 8. Some of you can do this in your head pretty easily. Some of you might like to write it down just to be careful. I like to write it down. So we got y equals 11, and then y equals negative 5. Those are my two possible answers. Okay? And there are two possible answers. That is absolutely correct. When you think about this on a graph, if you have the point 2, 3, and I'll try and draw like a real small picture of this real quick. If I had 2, 3, which is like maybe somewhere right up here, then there's 8y, right? So it's going to be somewhere over here. The point is going to be somewhere over here along this green line that I've drawn. So I could have maybe a point that is down here at negative 5, let's say, or I could have a point that's up here at like 11, and their distances are the same, right? So there are two spots where those distances could be the same. There are situations where only one will work, but in a lot of these, you're going to have two separate answers. Okay. Uno más, uno más. Let's simplify this bad boy. So how do I add all these together? I can't just add all these numbers that are in the radicals and call it a day. It does not work that way. Ooh, that rhymed. So I'm going to break these down, factor tree style. Well, this is going to go 9 and 2. What's the square root of 9? That's 3 root 2. Okay. How about 32? 32 I'm going to pop up here so I have space. 32 would be 16 and 2. If I break it up into perfect squares and some leftovers. So what's the square root of 16? That's 4 root 2. And what can I break 75 down into? Well, my biggest perfect square I can divide out is 25, and I'm left with 3. And what's the square root of 25? That's 5, and then the 3 can't come out. So now I can put these two together, and I'll just add the coefficients, which is 7 and root 2. You basically treat it as if you had like 3x plus 4x. It's 7x, right? The root 2 is like that variable in a way. And then I've got 5 root 3. Boom! Donezo! I know these spell works are a little bit long, but they are quite helpful if you need a little bit of review of that algebra. Alrighty, so here we are into the Pythagorean Theorem. A little Pythag action. It's a wonderful, wonderful theorem. All right, there's Pythagoras. He was an old dude made out of stone, and he lived from 582 to 507 BC, right? And Pythagoras and his followers believed that everything in life could be described through the numbers. That's right. That's right, children. Numbers are there to make sense of the world. So some of this might be a little review, so we'll go quickly. The anatomy of a right triangle, right? We've got our vertices A, B, and C. We notate our sides across from the angle with the lowercase version of it, right? That's why I've got these lowercase letters that are across from the angles, okay? Little a, lowercase a is across from uppercase A, the angle. Cool? All right. Now these are called the legs, and this is the hypotenuse. Hypotenuse. So the hypotenuse is always going to be my longest side, as it is across from the right angle, which is the biggest angle. So biggest side is across from the biggest angle. Smallest side is across from the smallest angle. We know that from a previous lesson here. So what is my Pythagorean theorem? Oh, I think that you guys know this. I'm sure hoping you do. A squared plus B squared equals C squared. If you didn't remember it right then, I'm sure that rings a bell. You've probably seen it before. You probably talked about it with your friends, or maybe at Thanksgiving dinner or something like that, right? There we go. There's also the converse of the Pythagorean theorem. If A squared plus B squared equals C squared, then you have a right triangle, or even just a right angle, okay? So that is the converse. You can, if you have a right triangle, you can use the Pythagorean theorem. If you want to figure out if it is a right triangle, you can use the Pythagorean theorem if you know all the sides. Cool? And we should remember that from when we were classifying triangles as like scalene and isosceles and equilateral. And then we also talked about the angles, acute, obtuse, and right. So if that c squared is a little bigger than the a squared plus the b squared, well, then you know it's obtuse. You know that this angle down here is a little bit bigger than a right angle. If the c squared is less than the a squared plus b squared, then you know that angle is acute. It's a little less than a right angle. And that's something that you could use in an application of, like, say you're trying to frame in a window or a door, or you're framing out like what's going to be a concrete patio. You want to check for right angles. You can do that with a tape measure, which is pretty dope. All right, we're going to find some missing sides. I know that r is root 38. I know that x is 2 root 5, and then we want to find out what y is. Well, remember, it's a squared plus b squared equals c squared. Well, what's my c in this case? That's the one that's across from the right angle, right? So that's my that's going to be my c squared, so root 38 squared. My a and b does not matter which one's which, so I'll just do 2 root 5 squared plus y squared. Anyone know why those parentheses are so important here? Why those parentheses are important around that 2 root 5? Very good, children. Yes, indeed. I could read your mind through the video. You are right. This would need to be applied to both the 2 and the root 5. Otherwise, no bueno. So 2 squared is 4, and root 5 squared is 5, so you end up getting 4 times 5, which is 20, plus y squared equals 38, because that just cancels that. If I subtract the 20, I get y squared equals 18. And if I square root that and then break this down into 9 and 2, I get 3 root 2. So that would be what I get for y. Now, normally when we square root, we end up with like a plus or minus. Would I have the plus or minus here? No, because we're talking about a length, right? That's a length of a side there for y. We can't have negative 3 root 2 for a side length. That's cray-cray. So just the positive in this case because of the context of the problemo. Okay, let's find an altitude of an equilateral triangle if the sides are 6 centimeters. Well, if the sides are 6 centimeters of an equilateral triangle, right, they're all going to be 6. They're all congruent. My altitude drops down and forms a right angle, right? It's perpendicular to that opposite side. Now, the altitude of an equilateral triangle is actually also going to bisect that opposite side. Happens in an isosceles as well as an equilateral triangle. So if it's bisected, what are these two sides? Well, they are 3 and 3. And I want to find the altitude, right? I'll call that x. Woo! All right. So why don't I do, well, what's my c in this case? It is across from my right angle, as always. So let's draw that. Whoop, there's my c, right? And now my legs, doesn't matter which one's which. 3 squared plus x squared equals 6 squared. So I get 9 plus x squared is equal to 36 squared. If I subtract 9, I get x squared. Oh, not 36 squared. My apologies. Let me just pop that away there like it never happened. All right. So if I subtract 9, I'm going to get, let's see here, 27. Yeah? And if I square root that, x is equal to, well, break that down, 9 and 3. Square root of 9 is 3, root 3. Okay. We're going to start seeing some of these root 3s again here relatively soon. We'll maybe pop back to something like this and talk about it then. But for now, Pythagorean theorem did the trick. Figured out that x, that altitude. Good to go. All right, let's find the perimeter of a rhombus with diagonals 6 and 10. I remember seeing a lot of these problems like this, or squares and all sorts of stuff with diagonals. Mainly, well, think about what happens with diagonals of a rhombus or of a square or of a kite. That is not a very good rhombus. Oop. All sides congruent in a rhombus. There, that's a little better. What do we know about our diagonals of a square, a kite, or a rhombus? Well, they are perpendicular. They form right angles, which ties in perfectly with the Pythagorean theorem. So the diagonals are 6 and 10. What do those diagonals do to each other? They bisect them. So this becomes 3 and 3. This becomes 5 and 5. So I want to find my perimeter, which means I want to find a side length, right? And then what do I do with those side lengths? Add them all up. So 3 squared plus 5 squared equals x squared. That x is across from my right angle. That's why it's my c squared. So I get 9 plus 25 equals x squared. So we get 34 equals x squared. And if I square root both sides, x equals square root of 34. I cannot break that down. That's what it is. Well, how many sides do I have? I have 4, so my perimeter is 4 times each side length there, or 4 times the side length. So I get 4 root 34. Woo-woo! Each side's going to be the same. That's very interesting. If you're like, hey, well, how are if my diagonals are perpendicularly bisected, you can clearly see that you're going to get the same measurement for each one of these sides, right? Because the same Pythagorean theorem is going to show up. All right, so given the coordinates of triangle ABC, verify that the triangle ABC is a right triangle. Now, you can see, that we have vertical and horizontal lines, so yeah, with our slope, you could definitely show that this is a right angle. But we want to show it with Pythagorean theorem, okay? So how do I show that with Pythagorean theorem? Well, I got to know my side lengths first. I can count this one out to be 5. I can count the other one out to be, it looks like 4, right? From 2 to 6 and from 2 to 7. Okay, and then what could I use to figure out BC? Well, BC, I could do distance formula from 2, 7 to 6, 2, right? So if I subtract my x's, I get, 6 minus 2 squared, and if I subtract my y's, 2 minus 7 squared. So that's 4 squared, which is 16, and negative 5 squared, which is 25. So that equals, 16 plus 25, that's 41. Okay, so it's the square root of 41. Okay, that's what I get from distance formula. Well, let's see if my Pythagorean theorem would hold true. So I get 5 squared plus 4 squared is equal to, well, I guess we don't know if it's equal to. We'll leave a little box there. We don't know. Square root of 41 squared. Okay. So let's work it out. Well, 5 squared is 25 plus 16, right? And then add those together, I get 41. Well, if I square, I'm just going to bring this right down. If I square that square root, those cancel, right? And I get 41. Are they equal? Yes, it is a right triangle. Woo! Some of you may have noticed this all the way back up at that first step. You'd be like, dude, Mr. Allen, this is the exact same thing that I just saw in my square root, right? When I did the distance formula. Well, fun fact, distance formula, all that does is it creates a right triangle with that diagonal line, that slanted line, as my hypotenuse. That's all your distance formula does. It creates a right triangle to calculate the length of a hypotenuse. It is the Pythagorean theorem, okay? And uses that to figure out that length. That's pretty cool there, don't you think? I think so, but maybe because I'm super into math and nerdy. So back to something that we alluded to earlier, we're classifying triangles. If your c squared is less than a squared plus b squared, sorry for the terrible math type that went in here. Obviously, it did not make it into exponents. If the c squared is less, it's acute. If the c squared is equal, then it's a right. And if the c squared is bigger, then it is obtuse. Okay? Cool. And I use this all the time if I'm, say, framing up something that's rectangular or that I want to be rectangle. I might measure something that I know, 3 squared plus 4 squared is equal to 5 squared, right? It's a common one we'll learn about later is a 3, 4, 5 triangle. This is 9 plus 16 equals 25. So what I'll do is I'll measure, say, 3 feet in this direction and 4 feet in this direction, and then I'll take a tape measure from here to here, and I'll check to see if this is 5 feet, right? Now, if it's over 5 feet, right? If it's bigger than 5 feet, I know that this angle right here is bigger than a right angle. It's over 90 degrees. If it's less than 5 feet, I know it's less than 90 degrees. But if it's dead on at 5 feet, I know I've got a right angle. Okay? So I can use that. I can make a couple marks on the piece of wood and measure between them to see if I've got that right angle. So it's one way you can verify that. One way that's useful in the real world. So let's see here. What kind of triangle is this? A good, a test question we can ask you. Classify the triangle by the angles given the side lengths below. So we're going to pop this into our Pythagorean theorem. So if I do 12 squared, our Pythagorean theorem converse or corollary, if you will. 12 squared plus 36 squared and then 34 squared. And put a box. Oh my goodness, what did Mr. Allen do wrong? What should be my biggest side? 36, not 34. Come on now. I did that on purpose. Oh my goodness. 34 squared. Pop that box. 36 squared. Boom. Okay, make sure your biggest side is your c squared. If things are weird and radicals, you're not sure, plug them in your calculator, get some decimals, and know that you're putting your biggest side as your c squared. Okay? So if I were to work this out, we've got 144, oops, boom, and 34 squared, let's see here, 34 squared is going to be 1,156, and then 36 squared, it's going to be 1,296. Okay. So what is 144 plus 1156? What's up? Miss Zaleski just popped in the room. All right, so we got 1,300 and 1,296. So what do we know here, children? Well, I would say that the a squared plus the b squared is bigger than the c squared, meaning the c squared is less than the a squared plus b squared, so it is acute, meaning that angle is a little bit less than 90. Booyah, dogs. Miss Zaleski, are you having a wonderful day?
Yes. I'm sorry to interrupt.
It's okay. It'll just be in here for all of eternity on the YouTubes. Peace.
Think good thoughts.